Okay, so students, I assume you have already watched the video on the nails pressing or rather the balloon pressing on the nails. Okay, so I will talk about that a bit later, but I would like to bring up two things that we have learned previously, okay, about balance and unbalanced forces. Okay, now we all know that an object is on a table, right? It's not moving, is experiencing balance forces where I have my weight pressing down vertically and also the table pushing it up vertically. So this is called a normal reaction force. Okay, now in this case, both forces are the same. Therefore, it will not move. Alright, but I would like to bring your attention to the case where it starts to move. So let me bring up my eraser. Alright, when it starts to move, can you take like 10 seconds to think under what circumstance will the box go down? Alright, I hope you have a slight idea on how the box will move downwards. Okay, so I assume that you would have gathered or rather concluded that in order for the box to go down, your weight must be more than the normal reaction force. Alright, so anything more than this, if I just put on a number, this will cause the box to move, or in terms of Newton's second law, we say that it starts to accelerate downwards. Alright, now so for objects to move downwards on the surface, right, other than just having unbalanced forces, okay, there's another concept that we want to touch on today, which is called pressure. Alright, so let me erase again everything here. Alright, as you have seen just now about the balloon on the nail, okay, you saw that for one balloon, okay, and when I put it near a nail, right, it bursts. Okay, same thing for when I bring two nails to a balloon, it bursts too. Alright, but when you saw that you have 100 nails, okay, and I put a balloon down, you realize from the video that it does not burst. In fact, the nails went through the balloon. Sorry for double S. Alright, so this, I believe, has to do with pressure. Right, you have learned last year in secondary 2 that pressure is the force over area. Right, let's take maybe 5 seconds to just recall that formula. Force over area. Okay, now what happened when the experimenter in the video changes from 1 nail to 2 nails to 100 nails. The balloon he used were the same. So what did he change? Alright, he changed the contact area. Right, for a single balloon, the contact area is as small as a dot here. Right? For two balloons, the contact area is just twice the size, which is still pretty small. But what if I have 100 of such nails? My area becomes bigger, or area increases. Alright, so let me erase this again. So we know that pressure is force over area. Alright, we know from the video that when A, the contact area, is small, the balloon bursts. Now, I hope that you understand how this leads to pressure. So can you take maybe 10 seconds again to think what happens if the A is small? What happens to the P? Is it big or small? Now wait, I hope you got the answer. Alright, now when I take a small nail, or rather just one nail, and I put it on the balloon, it bursts. Now this indicates that my pressure is very large. Alright, now when I put on 100 nails, which means to say my contact area now increases. My balloon didn't burst. So what can I say about the pressure? Take another 5 seconds to think about it. Does it go up from case number 1, or does it go down? Right? Jensen Hong? I think you got the answer. It should be going down. Alright, so this is the same as saying me putting a nail into your head. Alright, do you think your head will hurt more with one nail, or when I have 100 nails? Now think about it, your head is now the balloon. Alright, I think you would rather 100 nails to go in rather than one. Okay, now take the next 10 seconds to go through this idea of size of the contact area and also the pressure generated. Okay, so in short, if the contact area A goes up, the pressure goes down, provided my force stays the same. Right, let's move on to go through the formula itself. Okay, now pressure is created when I have a force acting on an area. Okay, which means to say that pressure only works upon contact. Alright, there's absolutely no pressure if I just put a nail poking into air. It looks pretty stupid though. Alright, so let me just go through the formula itself. Okay, pressure is force per unit area. This is the definition. Alright, now the unit for force, as we all know now, by now, if you still do not know, I think you have to see me, is newtons. And area is a derived quantity. Area comes from length multiplied by its length. Right, so if you work out the units, you should get a meter square. Alright, so now pressure has a unit of Newton per meter square or square meters. Alright, let me introduce you another unit that is associated to pressure, which is called PA, Pascal. So Newton, one Newton per meter square is exactly the same as 1 Newton. Sorry, let me erase this. Is exactly the same as 1 Pascal. Alright, take 5 seconds. Look at this and this to digest it. Alright, let's move on. Now I would like to show you, or rather highlight to you, one common mistake made by students. Alright, now we know that the formula for pressure is Newton per meter square. Now it is also possible that my pressure's formula can be written like this. Now this is not the SI unit. This is the SI unit. Alright, but it is still correct to write it this way. So now if you are required to write it this way, right, you are to adjust your units in the question accordingly. Okay, so now maybe just let me run through one simple example. So I have maybe an elephant standing on the ground. Right? Don't laugh at my photo or my picture. I'm not good at art. So will you stop laughing? Still laughing? Come on. Okay. Now, the elephant weighs a total of 10,000 newtons. Alright? Now, area of contact. The contact area is essentially all these 4 areas here. Alright? So let's say one leg has an area of 900 cm square. Right? So if I have 4 legs, okay, sorry, 4 legs, it should work out to 3,600 cm square. So essentially, the pressure that the elephant exerts on the ground is 10,000 newtons over 3,600 cm square. So please work this out. Alright. Now in the event where you are expected to give your answers in Newton per meter square, all you need to do is to change this to this. Now, just let me do a short recap. 1 meters is 100 cm. 1 meter square is 100 square cm square, which will work out to 10,000 cm square. Alright, do the mathematics by yourself and you're good to go. Okay, so now this concludes the main body of the video lesson. Now I will just do another short summary video lesson on pressure, and please complete the work that comes together with the instructional sheet. Alright, thank you.